There is a moment, usually an ordinary one, when a person looks up at the sky and senses something quiet pressing back. It might happen during a late walk, or while standing at a window, or when the mind wanders during a pause in conversation. At first it feels familiar, the same sky that has always been there, the same soft awareness of a world extending above our heads. But if the thought lingers even slightly longer than usual, if attention rests on the space rather than the scenery, the familiarity begins to shift. The sky ceases to be a ceiling. It becomes something without a boundary, a depth rather than a surface, and the mind instinctively leans away from it, as if nearing the edge of a drop. The discomfort is subtle, not frightening, just enough to make us retreat to the comforting shapes of clouds and the predictable light of the moon. It is in this tension, between what is simple and what is vast, that the story of cosmic scale begins. We are creatures who evolved to feel safe in enclosed spaces, in forests, savannas, and shelters. Our brains were sculpted by the need to understand things that were close enough for us to touch, cross, lift, or throw. Distance was never an abstract concept, it was an immediate calculation of effort and risk. We learned the length of a stride, the reach of an arm, the time it takes to run from one shadow to another. Everything beyond this range was simply far, a word with no need for further detail. The sky did not demand comprehension. It merely reminded us when to wake and when to rest. So when we pause long enough to consider the space beyond it, the mind hesitates, caught between instincts made for a small world and the quiet immensity that surrounds it. The familiar feeling of distance, of something being across the room, down the street, or over the horizon, gives us confidence that we understand space. We assume that if we just scale these distances upward, we will eventually reach the size of the solar system, the galaxy, the universe. But the mind is built on shortcuts, and one of its deepest shortcuts is the intuition that distance behaves in human terms. This assumption holds until we reach the edges of our everyday experience, and then, with no warning, it collapses. What lies beyond those edges does not bend to our expectations. It expands at a rate we cannot internalize. It stretches into silence. Imagine a simple idea, the distance between you and something familiar. A tree you can see from your window. A building across a quiet street. These distances make sense because they belong to your scale. They respond to your movement. You could walk to them, circle them, study them, and rely on your perception to stay consistent. Even when the distance grows, to a landmark across a valley or a ship on the horizon, the mind still works with it. You can imagine the steps, the hours, the effort. You remain anchored. But cosmic distance does not anchor us. It erases those steps and hours and stretches the imagination beyond anything tied to the body. When we begin to think about distances that light must cross, about the time required for a signal to travel, or the gap between planets suspended in their slow orbits, we encounter something fundamentally different from the distances we evolved to understand. These measurements cannot be walked, or paced, or visualized through memory. They belong to a realm where human intuition falters. And yet, we try to grasp them, layering analogy on analogy, searching for clarity in numbers that behave more like cliffs than pathways. The mind resists not because it is incapable, but because it is being asked to imagine an absence. Cosmic space is not defined by the objects within it but by the emptiness between them, and emptiness does not offer reference points. When you walk across a field, the ground holds you, the air surrounds you, the horizon guides you. But imagine trying to understand a field so large that its edges might as well not exist, a field where every step forward fails to bring anything visibly closer. The experience becomes alien, not because it is dangerous or chaotic, but because it offers no foothold for understanding. This is where our journey begins, not in the vast universe itself, but in the quiet conflict between the world we are built to understand and the one we inhabit. The immensity around us is not loud. It does not demand attention. It waits in silence, unchanging and unconcerned. Yet when we choose to look closely, to think slowly, and to follow distance where it leads, we feel the subtle pressure of scale that dissolves our certainty. The universe does not overwhelm us, rather, it reveals the delicate boundaries of the human mind. In the next steps of this journey, the familiar world will serve as our starting point. We will trace the limits of our intuition, learning why certain distances make sense while others elude us. We will explore how the body, the brain, and the environment shaped a narrow window of understanding, and why stepping beyond that window requires careful, patient thought. The goal is not to master the universe or shrink it into metaphors. It is simply to see it clearly, to sit with the discomfort it brings, and to understand why that discomfort matters. For in the quiet immensity that surrounds us, our place is not diminished but clarified. We are small, yes, but never lost. The universe is not hostile to our understanding, it simply waits for us to approach it slowly. When we try to understand the universe, we usually begin with what we already know, the world scaled to human proportions. It is a world in which distances are not just numbers but lived experiences, where moving from one place to another draws on memory, muscle, and expectation. Every step has weight. Every journey has a rhythm. Even when we travel far enough that the body cannot carry us, when we use cars, trains, or planes, we remain grounded in a sense of motion that fits comfortably within the span of a lifetime. Our brains do not struggle with these distances because, on an evolutionary level, they belong to us. They are the scales for which our minds were shaped. Think of the distances you encounter each day, often without noticing. The stretch of a hallway. The width of a room. The distance between two parked cars, or the time it takes to cross a familiar intersection. These are not abstract quantities. You do not calculate them or convert them. You sense them. You feel them in your stride length, in the way your eyes shift from one object to another, in how long it takes you to move your hand from one point in space to the next. Every one of these distances is intimately tied to your body. They are comprehensible because they exist on a scale where perception and physical movement reinforce each other. This connection between movement and understanding is so deeply ingrained that we rarely notice it. If someone asks how far the kitchen is from the living room, you do not quote numbers. You do not retrieve a formal measurement. You imagine the act of walking. You imagine turning, stepping, and arriving. Distance becomes a simulation of effort, a resonance between the mind and the world. And because this relationship is intuitive, we trust it, even when the distances grow. Consider a neighborhood. You know how far it is to a friend's house or to the nearest grocery store. These distances might require several minutes of walking or a few moments of driving, yet they remain internalized. You have repeated them enough that they have become mental landmarks. Even when you cannot see the destination, you feel its position relative to you. The mind excels at this scale, holding vast networks of paths and places in a coherent mental map. If you expand this range even further, to the size of a city or a region, your intuition begins to stretch but not break. You understand that traveling across a city might take 30 minutes or an hour. You understand that a highway connects one town to another and that a plane can cross a country in several hours. These distances begin to exceed the limits of the body, but they still fit within the limits of memory and experience. We have all traveled long enough to form an intuition about what hours of motion feel like. We can estimate how far something is based on the time required to reach it, and so these larger distances inherit meaning from our daily experience of shorter ones. The key here is that human intuition about distance is not actually about length. It is about time and effort. A distance that takes 1 minute to walk feels small. A distance requiring an hour feels large. A journey that takes a day feels immense. But the physical measurement, the number of meters or kilometers involved, barely registers compared to the emotional and physical memory of the time it consumed. This is why our minds remain comfortable even when dealing with distances we cannot see entirely. As long as we can translate them into familiar units of experience, they remain grounded. Yet this comfort is fragile. It can be disrupted easily by removing context. Consider an unfamiliar number, like 1,000 kilometers. You might know, in a factual sense, how long 1,000 kilometers is, but without tying it to a specific journey you've taken, the number floats. It becomes a concept rather than an experience. You might compare it to the width of a country or the length of a long trip, but even these comparisons rely on the memory of time spent moving, rather than on the spatial magnitude itself. This reveals something important about the human mind. We do not understand distance in isolation. We understand it through the lens of action. Distance shapes choices, where we go, how we travel, whether a task is worth the effort. Throughout human evolution, this understanding served us well. It guided us to resources, helped us avoid danger, and allowed us to navigate environments with remarkable precision. But it did so within a narrow band of scales. Very short distances, such as those between objects within arm's reach, and moderately long distances, like those between nearby landmarks, were all that mattered. Anything far beyond these ranges held little practical significance. The sky began where usefulness ended. We knew it was high above us, but its height did not change our behavior. The stars were lights, patterns, stories, not destinations. They had no associated movement or experimental memory. There was no effort to calculate. No journey to simulate. They were, in every way, outside the domain of human intuition. This is why, even today, when we possess extraordinary tools for measuring and understanding space, our instincts still pull us back toward the familiar. We may know the distance between cities and continents, but our minds remain anchored to the scale of the body. We understand a kilometer because we know how long it takes to walk one. We understand 100 kilometers because we know how long it takes to drive that far. The relationship between distance and time gives meaning to space, and whenever this relationship breaks, so does our intuition. To see this clearly, imagine standing on the shore and watching a ship disappear over the horizon. You know, intellectually, that the ship is not falling off the edge of the world but simply following Earth's curvature. Yet the moment it vanishes, you lose intuitive grasp of its distance. You can imagine it continuing forward, but the connection between sight, perception, and movement is gone. The visible world has boundaries, and beyond them intuition begins to fail. Or imagine looking at a mountain in the far distance. Its size and apparent position can mislead you. It may look closer than it is because your brain attempts to scale it using familiar cues. But mountains defy this scale. Their sizes distort your perception, making the relationship between effort and distance unreliable. If you've ever attempted to hike toward a peak that seemed reachable in an hour but took an entire day to approach, you felt your intuition slipping as the rules it relies on changed. This slipping becomes even more pronounced when dealing with the scale of Earth itself. We know the planet is enormous compared to our daily experience, yet we often treat its size as manageable. We cross oceans by aircraft, not because oceans are small, but because technology compresses the time required to cross them. A journey that should feel vast feels modest. An entire hemisphere becomes an overnight trip. Our intuition adjusts, but never fully absorbs what these distances represent physically. The Earth's circumference is about 40,000 kilometers, a number far beyond the scale of human movement. But because we can traverse the world in less than a day, the number loses its weight. Technology shrinks the world emotionally even as it remains immense physically. And this emotional shrinking is the foundation upon which our modern sense of distance is built. We are surrounded by numbers that exceed human intuition: the depth of the ocean, the altitude of flight paths, the thickness of the atmosphere. Yet we accept these numbers easily because they remain anchored to physical processes we experience indirectly. We breathe because the atmosphere surrounds us. We fly because engines lift us. We sail because water supports us. These experiences give us footholds, allowing us to approximate the size of Earth through sensation, even if imperfectly. But when we leave Earth's surface, even in thought, that sensory anchor disappears entirely. There is nothing to push against, no medium to travel through, no environment to simulate with the body. Space removes all the intuitive cues we rely on, leaving distance as a raw abstraction. Without effort and time, numbers become unmoored. Without movement, distance becomes unfamiliar. And without familiarity, the mind begins to drift. This grounding in human scale is essential before we expand outward. If we do not first see the limits of our intuition, the scales we encounter later will feel exaggerated or unreal. But they are neither. They are simply distant from our experience, waiting patiently beyond the edges of sensation. In the next steps of this journey, we will begin to lean beyond those edges, moving from the comfort of human-scaled distance into the first hints of the quiet immensity that surrounds Earth, the Moon, and the planets beyond. When we step beyond the distances shaped by our bodies and our daily movements, the first true expansion we encounter is not to another planet or star, but to the space just beyond our atmosphere. It begins with the Earth and the Moon, a pair so familiar in photographs and diagrams that we rarely consider the true distance between them. We see images of the Moon nestled neatly beside Earth, glowing softly, as though it floats just above the planet's surface. It feels close, companion-like, a serene neighbor keeping nightly watch. But this closeness is an illusion crafted by scale models that fit comfortably on screens and in textbooks. The real Moon is far. It is so far that our most basic intuitions fail immediately. If you were to shrink Earth to the size of a standard globe, about 30 centimeters across, the Moon would not be hovering just above it. It would be more than 9 meters away, roughly the length of a large room or a modest apartment. This is the first hint that planetary distances behave differently from anything we know. The space between Earth and the Moon is not a narrow gap. It is a gulf. The Moon is not tucked near Earth. It drifts on the edge of what feels like an invisible boundary, a frontier between the familiar and the unfamiliar. Even astronauts, who traveled this distance in the early decades of space exploration, described the journey as entering a realm that felt detached from any known landscape. Once Earth begins to shrink behind the spacecraft window, the concept of motion changes entirely. There is no reference point. No roadside blur. No horizon shifting with each passing moment. Only the slow, steady drift of two bodies held together by gravity, and the expanding sensation of moving through a silence with no floor beneath it. Yet the Earth-Moon distance, on cosmic terms, is tiny. Light takes just over 1 second to travel between them. A spacecraft during the Apollo missions took about 3 days. For us, that feels long. To move for 3 days straight without stopping, without a landscape, without anything passing beneath you, is an experience far outside the domain of ordinary life. And this is precisely where human intuition begins to crack, not when distances become impossibly large, but when they become just large enough that familiar cues disappear while still remaining small on the cosmic scale. The space between Earth and the Moon is not empty because it lacks objects. It is empty because it lacks meaning for our senses. On Earth, even when nothing surrounds you, standing in an open field or floating in the ocean, you are still immersed in some environment. There is air to breathe, gravity to feel, temperature to sense. In space, these cues vanish. The emptiness is not simply the absence of matter. It is the absence of context. This absence grows dramatically when we move from the Earth-Moon system to the broader architecture of our solar system. The next major step outward brings us to the distance between Earth and the Sun, a distance so large that even words like far cease to hold descriptive power. Light takes 8 minutes to cross it. A spacecraft, moving far faster than anything on Earth, takes months. If you imagine Earth and the Moon again on that same scale model, with Earth the size of a globe, the Sun would be about 35 meters across and more than 3 kilometers away. 3 kilometers is a distance we can comprehend, but not when the object occupying it is so vast that it dwarfs every feature of our model world. The Sun is not just far away, it exists on a scale that pushes against the edges of our imagination. Planets orbit within this vast expanse like small islands scattered across an ocean. They are not arranged neatly or evenly. Their spacing varies dramatically. Mercury is relatively close to the Sun, Venus sits farther out, and Earth orbits at a distance that just happens to support life. But beyond Earth, the gaps widen quickly. Mars, our next planetary neighbor, is tens of millions of kilometers away at its closest and far more at its furthest. These numbers begin to outgrow intuitive meaning. We can compare them. We can visualize them as points on a line. We can memorize them. But we cannot feel them, because there is no basis in our physical experience to do so. This is why the solar system is frequently depicted as a series of concentric circles on a flat diagram. It is the only way to fit something so vast into something the size of a page. However, these diagrams unintentionally distort our intuition. They suggest that planets orbit one another at reasonable intervals, that moving from one orbit to another might feel like stepping between stepping stones. In reality, the solar system is mostly empty space, punctuated by small points of matter that appear meaningful only because we happen to inhabit one of them. Even travel times within the solar system demonstrate how misleading our intuition can be. A spacecraft like Voyager 1, launched in the 1970s and traveling faster than any human-made object before it, took more than a year to pass Jupiter, and longer still to reach Saturn. These are worlds that appear close when arranged on a diagram, but in truth they lie at distances that required prolonged and continuous motion at extraordinary speeds. The solar system is not compact, it is sprawling. Yet these are the scales we can still measure with kilometers and hours and days. They remain within a range where our mathematical tools work, even if our intuition struggles. But this struggle is important. It signifies the moment where our familiar sense of distance, built from the slow evolution of human experience, begins to detach from the reality of space. The emptiness between planets is not a backdrop. It is the dominant feature of the solar system. Planets are exceptions, not the rule. As we consider these distances, we begin to encounter a new dimension of difficulty. The speed at which we observe or measure movement becomes crucial. On Earth, speed does not drastically change our sense of distance. Walking, driving, flying, all these are familiar modes of transportation that maintain continuity between effort and outcome. But in space, where distances are so great that even light takes time to travel, speed becomes a defining factor. A slight change in speed can alter the meaning of a journey by years, decades, or centuries. Suddenly, distance is not just space. It is time. This intertwining of distance and time appears first with the Moon and grows exponentially as we move outward. It invites a new kind of reflection, not about the numbers themselves, but about what it means to exist in a universe where even the nearest objects lie at distances so vast that they require time to be understood. If you've been enjoying this slow, deliberate unfolding of scale, this careful walk from what is familiar to what is quietly overwhelming, this might be a good moment to join the channel. It supports the kind of long, reflective explorations that unfold at their own pace rather than rushing to conclusions. If this journey resonates with you, subscribing helps ensure we can continue traveling outward together. That is CTA number 1, offered gently, without interruption. Returning to our path, consider again the Earth-Moon distance. It is often cited as roughly 384,000 kilometers. This number seems manageable at first glance because it lacks emotional context. But imagine attempting to drive this distance in a car. Even at highway speeds, traveling continuously without rest, it would take many days. Imagine walking the distance, it becomes absurd. Imagine trying to visualize it in your mind's eye, the number begins to lose traction. And yet, this distance is tiny compared to the gap between Earth and Mars when the two planets are far apart in their orbits. That gap can exceed 400 million kilometers. Light takes more than 20 minutes to cross it. A radio signal, moving at the speed of light, sent to a Mars rover takes time to arrive, and its response takes time to return. Communication becomes a conversation with a built-in pause, a delay dictated by the fabric of space itself. These distances shape both our technological achievements and our limitations. They define the delays experienced by spacecraft, the trajectories required to save fuel, and the orbital mechanics that determine when missions can launch. Distance in space is not simply a matter of measuring how far something is. It dictates how we interact with the universe and what we are able to experience within a human lifetime. The emptiness itself also plays a role. Space is not filled with objects evenly distributed. It is mostly void. The vast majority of the solar system contains nothing but particles of dust, stray atoms, and occasional wandering ice or rock. The distances between planets are not filled with scenery. There is no environment to observe, no features to guide movement. Without constant measurement, a spacecraft could drift indefinitely, lost not because of obstacles but because there are so few. As we move into the larger scales of the solar system, we begin to see the first hints that kilometers may not be adequate to describe the universe. They work for human travel, for planetary missions, and even for measuring the width of orbits. But as soon as we consider objects beyond our immediate cosmic neighborhood, the numbers inflate to dimensions that feel exaggerated. The universe does not become larger. Our unit simply becomes smaller relative to it. This growing mismatch between measurement and scale is the subject of the next phase of our journey. It marks the point where traditional ways of thinking about distance begin to fail, not because the universe becomes stranger, but because our tools, built for small worlds, begin to strain under the weight of immensity. We will explore those limitations soon, but first we will sit a moment longer with the silence between Earth and the planets, where the first cracks in our intuition reveal the enormity that lies ahead. As we continue outward, the first subtle truth becomes harder to ignore. The numbers we use to describe cosmic distance are not merely large. They are dysfunctional. They cease to behave in ways our intuition can follow. A kilometer is a small, friendly unit. It fits naturally into our lived experience. 10 kilometers is a long walk. 100 is a drive. 1,000 is the span of a region. 10,000 is the size of a country or a continent. We can stretch the meaning of a kilometer this far because we can loosely map it onto the world we know. But when we begin applying kilometers to the universe beyond Earth, the relationship between number and meaning collapses. Numbers escalate rapidly without offering insight. They pile up without deepening understanding. They produce scale without intuition. At first this happens slowly, almost gently, as though the mind has a threshold it does not reveal until pressed. But once crossed, the collapse is dramatic. Consider again the distance from Earth to the Moon, 384,000 kilometers. It is an amount that sounds enormous, yet for the most part, we accept it without difficulty. It is a number we can recite, compare, and visualize as a line. But beyond that number, something begins to shift. The distance from Earth to the Sun is approximately 150 million kilometers. The shift here is not merely quantitative. It is conceptual. The difference between hundreds of thousands and hundreds of millions is not a simple scaling. It is a transition into a region where our measuring tools begin to mislead us. When we say 150 million kilometers, we know it is a much larger distance than 384,000. But the human mind does not truly understand millions in spatial terms. We understand millions when discussing population, money, or quantities of objects, domains where grouping, repetition, and accumulation offer footholds. But distance has no repetition. There is no stack of kilometers. No heap. No collection. Spatial extension is not quantity in the same way. It is continuous, smooth, and unbroken. To stretch a kilometer into millions requires an imagination that cannot rely on tactile or visual experience. It must rely on abstraction alone. This difficulty intensifies as we proceed outward. The orbit of Mars varies between tens and hundreds of millions of kilometers from Earth. Jupiter orbits at more than 700 million kilometers from the Sun. Saturn orbits at more than 1.4 billion. Each new value increases the distance, but each also increases the sense of detachment. Billion is a word we can say easily, but in space it has no anchor. It floats untethered, like a balloon in a room too large for the mind to track. Kilometers fail because they were never intended for structures of this size. They were invented for earthly travel, for measuring rivers, roads, and borders. A kilometer works when distance can be traversed, or at least imagined, by human motion or machinery moving at human timescales. But when the journeys involved would require decades or centuries, even at extraordinary speeds, the unit loses meaning. It becomes a sound rather than a sensation. Scientists often navigate this difficulty with scientific notation, reducing immense numbers into manageable expressions like 1.5 times 10 to the power of 8 or 1.4 times 10 to the power of 9. Mathematically, this is elegant. Conceptually, it is even more meaningless to the untrained intuition. The notation does not shrink the distance, it shrinks the symbol used to represent it. The gulf between representation and reality widens further. This is not a failure of intellect. It is an inherent limitation of the human perceptual system. We evolved in environments where the largest distances we needed to grasp were those between hills, watering holes, and seasonal hunting grounds. Never in our history did our survival depend on understanding what it means for a planet to orbit hundreds of millions of kilometers away. The cosmos had no practical bearing on our day-to-day actions. Our senses remained bound to immediate surroundings, and our intuitions adapted to that scale. To see the full effect of unit breakdown, imagine measuring the size of the solar system entirely in kilometers. The edge of the region influenced by the sun's gravity extends more than 1 trillion kilometers outward. 1 trillion. A 1 followed by 12 zeros. A unit like this does not simply exceed understanding, it distorts it. The distance becomes incomprehensible not because it is beyond comprehension, but because the unit used is too fine, too granular, too small relative to the structure it attempts to describe. It would be like measuring the distance between cities using the width of a single grain of sand. The number would be accurate but absurd. We would learn nothing from it. The breakdown of kilometers is the first sign that our relationship with distance must change. We must shift from units that describe the familiar to units capable of expressing the unfamiliar. Not to exaggerate the universe, but to see it clearly. But before we move to those new units, it is worth reflecting on why numbers lose meaning at these scales. Large numbers are not inherently difficult. We can imagine a crowd of 10,000 people even if we have never seen one. We can imagine a mountain made of 1 million stones. But these are forms of aggregation. They involve many discrete pieces. Distance is not like that. It is not a collection of steps, it is the empty space between them. Empty space cannot be multiplied in the same way objects can. The meaning of the emptiness does not grow with the number. It stays empty. This distinction matters because it reveals something subtle about how our minds conceptualize the world. We are pattern-seeking, object-oriented beings. We respond to shapes, edges, colors, textures. Emptiness provides none of these cues. It is defined only by what is not there. As the emptiness expands, intuition loses traction. Space becomes something we must calculate rather than imagine. Our tools reflect this. The kilometer is an Earth-centered unit. It is tied to the size of the planet, to the distance someone might walk in 10 minutes or drive in a single minute. But the universe is not Earth-centered. It does not arrange itself according to our daily needs or sensory capabilities. The scales it presents are not human scales, and so our tools, useful though they are, eventually crumble under the weight of immensity. This crumbling becomes especially clear when we compare the distance to the nearest stars. Proxima Centauri, the closest star beyond the Sun, lies approximately 40 trillion kilometers away. 40 trillion. Even if we continue repeating the number, no amount of rehearsal will make it comfortable. It is not a failure of imagination but a mismatch between scale and symbol. Kilometers dissolve into irrelevance. The number becomes noise. This is why astronomers turn to different units, units that compress the absurdity into something that reveals structure rather than obscuring it. These units are not meant to make the distances small, they are meant to make them meaningful. Soon we will reach the most important of these units, the light year. But before we embrace it, we must fully understand the inadequacy of what we leave behind. Because that inadequacy teaches us something profound. The universe does not become strange when viewed at larger scales. It becomes honest. It stops conforming to expectations shaped by life on a single small world. If you've ever stared at a large cosmic number and felt your mind resist, felt a kind of gentle frustration at the impossibility of imagining millions or billions or trillions of kilometers, this would be a perfect moment to share that experience in the comments. If distance has ever challenged your intuition, or if these ideas leave you with more questions than clarity, your reflections help guide future journeys. That is CTA number 2, offered quietly, as an invitation rather than a request. It is worth remembering that the collapse of familiar units is not a flaw in human cognition. It is evidence of how specialized our intuition is. It is tuned to the size of our bodies, the speed of our movement, and the environments we evolve to navigate. And this specialization served us well for the entire history of our species until only recently, when science opened a window into scales far beyond anything evolution prepared us for. Standing at that window, we find ourselves confronting something new, a universe where distance must be redefined not in terms of walking or driving or flying, but in terms of light itself. Light becomes the bridge between the comprehensible and the incomprehensible. It becomes the only thing fast enough, consistent enough, and universal enough to measure the vastness ahead. In the next stage of our journey, we will step fully into this new framework. We will explore what a light year truly represents, not as a vague analogy for something very far, but as a precise, meaningful quantity that reshapes our understanding of time, space, and the structure of the cosmos. The moment we step beyond the limits of kilometers, we enter a new way of thinking about distance, one that feels unfamiliar at first because it is not rooted in the human body. It is not tied to walking, running, driving, or flying. It is tied instead to the motion of light, the fastest thing in the universe and the closest we have to a universal measuring rod. Light becomes our new companion in understanding the cosmos, not because it is poetic or symbolic, but because it is the only thing that behaves reliably across scales too vast for any human intuition. To understand the light year, we must first understand light itself. Light is not just illumination. It is a physical phenomenon that moves through space at a constant speed of approximately 299,792 kilometers per second, a number that, like all immense numbers, initially overwhelms. Even saying it aloud does not help. The mind cannot visualize something moving nearly 300,000 kilometers each second. What we can do, however, is observe its consequences. Light circles Earth more than 7 times in 1 second. If you could chase a beam of light around the equator, it would pass you again and again before you took a single step. In the time it takes to blink, light has traveled farther than any person has walked in their lifetime. And yet, despite its extraordinary speed, light still takes time to cross distances in the universe. This delay, this finite travel time, is the key to why the light year exists at all. Imagine light leaving a flashlight on Earth's surface. It travels upward, passing through the atmosphere in less than 1,000th of a second. It continues outward, passing the orbit of the Moon in just over 1 second, crossing the gap to the planets within minutes or hours depending on where they lie. But as the distances grow, so does the travel time. Light does not stretch or lag, it continues at the same steady pace. The expansion of distance makes the travel time meaningful. This is why astronomers eventually shifted from kilometers to light-based units. They reflect not only the scale of space, but the time embedded within it. When we describe the distance to the Sun as 8 light minutes, we are not simply choosing a more elegant unit, we are describing a physical truth. Even the universe's speed limit requires 8 minutes to bridge that gap. When we look at the Sun, We see it as it was 8 minutes earlier. Its present moment does not reach us immediately. It is always a short memory away. Time becomes inseparable from distance, and this fact becomes even more striking when moving outward through the solar system. Mars may be around 12 light minutes away at one moment and more than 20 light minutes away at another, depending on the alignment of the planets. The slight delay becomes noticeable in spacecraft communication. A signal sent from Earth to a rover may take 20 minutes to arrive, and another 20 minutes to return. Engineers send commands and wait, not because machinery is slow, but because space is vast. But all of these examples still reside within the solar system, where light travels inconveniently slowly but not yet overwhelmingly so. The leap from light minutes to light hours begins to stretch intuition. The outer planets lie several light hours away. Pluto orbits at a distance of about 4 to 6 light hours from Earth depending on their positions. This means that if Earth were to vanish suddenly, someone near Pluto would not know for several hours. Light would still be carrying the illusion of Earth long after the planet ceased to exist. This idea, that distance stores time, is one of the most profound aspects of cosmic scale. Every distant object we see is a memory. The farther we look, the older the memory. The light year formalizes this relationship. A light year is simply the distance light travels in 1 year. It is approximately 9.46 trillion kilometers, a number so large that no familiar analogy adequately conveys it. But the important insight is that the year, not the kilometers, is what gives the unit its meaning. A light year is not a count of kilometers. It is a duration of motion. It is the echo of light traveling for 12 months across an unbroken expanse. Understanding a light year does not require picturing trillions of kilometers. It requires understanding that light, moving faster than anything else in the universe, still needs a full year to cross it. Try to imagine sunlight traveling for 8 minutes, then extend that journey for an hour, then for a day, then a week, then a month, then for 12 consecutive months without stopping. That continuous motion, unwavering and uninterrupted, is a light year. Many misconceptions surround the term. Some people imagine it refers to brightness, as though it were a measure of light intensity. Others assume it describes time alone. But it is both a measure of distance and a reflection of time, physical separation expressed through the travel time of the fastest known entity. Using light years allows us to describe interstellar distances without drowning in trillions of kilometers. Proxima Centauri, the nearest star beyond the Sun, lies about 4.24 light-years away. This does not mean it is close. It means that the light we see from it tonight began its journey more than 4 years ago. The star we observe is not the star that exists at this moment, but the one that existed 4 years in the past. Its present-day appearance will not reach our eyes until several years into our future. Stars farther away exist even deeper in time. A star 10 light-years away shows us light from a decade ago. A star 100 light-years away displays a moment that predates many human lifetimes. And galaxies' vast collections of stars offer glimpses into ancient epochs. The Andromeda Galaxy, for example, is more than 2 million light-years away. The light arriving now began its journey before the earliest humans walked the Earth. When we look at Andromeda, we look into an age unconnected to any human experience, observing a cosmic structure as it existed long before our ancestors shaped tools or kindled fire. This relationship between light and time is not metaphorical. It is literal. The universe's immensity forces light into the role of a messenger, carrying snapshots of distant places across distances so large that even its extraordinary speed cannot make the universe appear as it is today. The farther you look, the deeper into the past you peer, until the concept of now fractures into billions of separate moments scattered across space. The light year, therefore, becomes not merely a distance but a way of understanding the structure of the universe. It reveals the universe as something stratified by time, where proximity is not just spatial closeness but temporal closeness. Two stars may be separated by thousands of light-years spatially, but the difference in the age of the light we see from them may stretch across epochs. Every direction we look contains a different layer of history. This is profoundly different from how we perceive the world around us. On Earth, light's travel time is negligible. When you observe a tree or a building, you see it as it is in the present moment. The delay is too small to register. Even when looking across a landscape, the difference between what is seen and what is happening is measured in billionths of a second. The connection between perception and reality is immediate. In space, immediacy disappears entirely. Everything is delayed. Everything is echo. Everything is memory. This realization is often unsettling. It challenges the instinctive assumption that what we see is what exists now. But this challenge also deepens the beauty of cosmic observation. The night sky becomes not a static dome of distant lights but a layered, dynamic record of the universe's past. It becomes a tapestry woven with threads of time, each photon a traveler carrying ancient information. The scale of a light year also reshapes how we imagine movement in space. On Earth, traveling a long distance might take hours or days. Even crossing oceans, which once required weeks of sailing, now requires mere hours by plane. But interstellar travel is restricted not only by distance but by the speed of light. Nothing can exceed this speed. This is not a limitation of engineering but a fundamental principle of the universe. If humanity were to build a spacecraft capable of traveling at a significant fraction of the speed of light, something far beyond our current abilities, it would still require years to reach even the nearest stars. The solar system, enormous as it is, becomes a small island compared to the ocean of stars beyond. The universe becomes a place where even the fastest conceivable journeys span lifetimes, and where communication with distant civilizations, if they exist, would take decades, centuries, or millennia. This is why the light year is indispensable. It frames the universe in terms of what can be known, what can be reached, and what can be communicated. It shapes our understanding of cosmic neighborhoods, determining which stars might be visited someday and which forever lie beyond practical reach. It defines the boundaries not of imagination but of physical law. And yet, for all its immensity, the light year is still only a stepping stone. It helps us describe the distances to nearby stars, but even it begins to falter when applied to galaxies, which span tens of thousands or hundreds of thousands of light years. Beyond them lie clusters and superclusters, structures measuring millions of light years across. At still greater scales, the observable universe itself stretches more than 90 billion light years in diameter, not because light has traveled that far in the age of the universe, but because space itself expands. These enormous distances lie ahead in our journey, but before we reach them, we must first appreciate the quiet, disciplined utility of the light year. It is the bridge between the human and the cosmic, the unit that binds space to time, and the language through which we begin to glimpse the true architecture of the universe. When we begin to expand outward using the language of light seconds, light minutes, light hours, light days, and finally light years, we discover that distance unfolds not like a ladder with evenly spaced rungs, but like a deepening field whose horizon recedes with every step we take. Each scaling upward is not simply a larger number but a new regime of experience, one where our connection to intuitive understanding weakens further. This expansion is not a jump from one unit to another, it is a gradual recalibration of thought, a reorganization of how space reveals itself. A light second, for instance, is easy enough to grasp. Light travels nearly 300,000 kilometers in that single second. This is a number beyond human speed, but not beyond human imagination. We can think of the distance between Earth and Moon, a little over 1 second of travel time for light. If Earth suddenly vanished, the moon's surface would continue reflecting its invisible glow for a brief moment. The delay is small, but perceivable. We can understand 1 second. We can even feel it. We experience it continuously in the rhythm of speech, in the pauses of breathing, in the interval between footsteps. A second is a human-scaled unit of time, and because of that, the light second carries a hint of familiarity. But when we transition to light minutes, something begins to loosen. A light minute is the time light takes to travel about 18 million kilometers. It takes sunlight just over 8 minutes to reach Earth. This fact, simple and elegant, compresses an enormous distance into a time interval we can measure using an ordinary clock. Yet even as we accept it, the meaning of that distance slips from our grasp. What does 18 million kilometers feel like? We cannot replicate it in motion. We cannot imagine a path that long in any earthly sense. Instead, we imagine 8 minutes, not the distance. The mind substitutes time where it cannot hold space. This substitution strategy continues as we expand to light hours. The outer planets, Jupiter, Saturn, Uranus, and Neptune, exist on the scale of light hours from Earth. Jupiter is about 35 to 50 light minutes away depending on alignment. Saturn lies over an hour distant at the speed of light. By the time we reach the outermost planets, light must travel for several hours before reaching them. If a sudden event occurred in Neptune's atmosphere, no observer on Earth would know until more than 4 hours later. Here again, we cling to time. Hours have meaning. Hours shape our days. We know what 3 hours feels like. We know how long it takes a movie to play, a flight to depart and land, an evening to pass. But using hours to understand the vastness of the solar system is like using a candle to illuminate a valley. The mind accepts the span of hours while the distance itself remains opaque. The emptiness between planets refuses to shrink no matter how we quantify it. It stands silently, indifferent to the discomfort it induces. When we move to light days, we detach further. The boundaries of the solar system stretch more than a light day away. The distance to the Oort cloud, the sphere of icy bodies that marks the extended gravitational influence of the Sun, is measured not in hours but in months. Some of the comets that drift here reside tens of thousands of astronomical units from Earth. For light to cross such regions requires time measured in days, then weeks, then months. Days are intuitive. We feel their cycle. But a light day is not a cycle. It is a continuous stream of motion at the universe's ultimate speed. A beam of light travels more than 25 billion kilometers in a single day. The number is too large to visualize, too large even to hold in short-term memory for more than a few moments. The mind yields, retreating into the comfort of temporal rhythm rather than spatial comprehension. This retreat becomes complete when we enter the scale of light years. A light year is not a unit that asks for understanding. It asks for surrender. It is too vast to internalize through analogy or imagery. Instead, we learn to accept it as an abstract concept that illuminates the structure of the universe. Yet even here, understanding grows gradually. To truly appreciate the immensity of a light year, we must trace the ladder from seconds to minutes to hours to days to years, feeling the expansion at each rung. Imagine beginning at Earth's surface. A single light second takes us 8 times around the planet. A light minute carries us into the inner solar system. A light hour delivers us past the gas giants. A light day pushes us toward the outer boundaries of the sun's influence. And after all of this, after traversing billions upon billions of kilometers, we have not yet traveled even a fraction of a light year. The nearest star is more than 4 light years away. The galaxy spans more than 100,000 light years. And beyond that lie structures so large that even light years begin to feel small. This is where our intuitive understanding dissolves completely. When dealing with interstellar distances, the mind cannot rely on time-based associations. A year is familiar. But a year of light's travel is not. It surpasses comprehension. We may imagine a calendar repeating itself 12 times, we may imagine seasons passing, we may imagine Earth completing an orbit. But these are symbols, not sensations. They do not convey the scale of motion inherent in light traveling continuously for that duration. To approach that scale, we must examine smaller increments again, reinforcing each step in the ladder. A light second is manageable. A light minute feels large. A light hour feels immense. A light day feels extraordinary. A light year feels impossible. And yet, the universe operates comfortably on these scales. Stars form, evolve, and die over millions or billions of years. Galaxies rotate over hundreds of millions. Light travels across clusters for billions of years before reaching us. The universe does not strain under its own immensity. Only we do. Reflecting on these scales requires patience, and if you find yourself listening to this and feeling the pull to continue, if the quiet immensity of these numbers stirs something curious or contemplative in you, this may be a good moment for a gentle invitation. If you enjoy long, thoughtful journeys through cosmic distance at a pace designed for reflection rather than rush, you might consider subscribing to the channel. It's an easy way to stay connected as we continue traveling through scales that challenge intuition. That is CTA number 3, offered softly, before we press further outward. Now we climb again. Light seconds take us from Earth to the Moon. Light minutes take us from Earth to the Sun. Light hours take us across the realm of the giant planets. Light days take us toward the interstellar frontier. But the solar system is only one tiny region in a galaxy filled with hundreds of billions of stars. To appreciate what a light year means in that context, imagine a sphere centered on the Sun with a radius of 1 light year. Inside this sphere, there are no other stars. The space is vast and almost completely empty. It includes the Oort cloud, where long-period comets sleep in their slow, frozen orbits. Yet even this enormous sphere does not reach Proxima Centauri. The nearest star lies more than 4 such spheres away. And throughout this region between stars, there are no planets, no moons, no dust clouds of significant density, only a sparse scattering of particles separated by distances too great to map meaningfully. This emptiness is not a failure of the universe to fill its space. It is the nature of gravitational structure. Stars carve out their own regions of influence, and the spaces between them become deserts of near-nothingness. Interstellar distance is shaped not by what exists, but by what does not. Only light crosses these spaces regularly, and even light requires years to complete the traverse. Consider the journey of a single photon leaving a star. It begins in the star's core, produced by a fusion reaction. Inside the star, it may take thousands of years to travel outward, bouncing from particle to particle along the way. Once freed into space, the photon moves unimpeded, traveling at the speed of light. It crosses the star's influence, enters the interstellar medium, and continues across light years of emptiness. If the photon is fortunate enough to be emitted in the direction of another star, it may reach it. If traveling toward Earth, it may pass telescopes, satellites, or the open air of our atmosphere. Finally, after thousands or millions of years, it may reach an observing eye or instrument, delivering a tiny piece of information about where it originated. This journey defines much of astronomy. Everything we know about the cosmos beyond our solar system arrives in the form of light that has traveled across unimaginable distances. The color of that light, the way it is absorbed, the patterns in its spectrum, these details reveal the temperature of stars, the composition of nebulae, the motion of galaxies. But every piece of light carries with it an inherent delay. We see stars not as they are now, but as they were when their light began its journey. The universe we observe is the universe of the past. This temporal layering becomes even more profound as we expand from light years to thousands of light years. Many stars in the Milky Way lie thousands of years away. Their light began its journey long before human civilizations rose. Some stars we observe may no longer exist, having ended their lives as supernovae. But because their final light has not yet reached us, we continue to see them as though nothing has changed. The universe's present is always veiled by the travel time of light. Expanding further still, entire regions of the Milky Way exist tens of thousands of light-years away. The galaxy is a disk roughly 100,000 light-years across. This span is so immense that even light, traveling for tens of thousands of years, cannot cross it quickly. If you were to send a signal across the width of the galaxy, it would not arrive until long after human civilization had transformed beyond recognition, long after languages evolved, long after cultures shifted. If humanity ceased to exist altogether, the signal would continue traveling through space, indifferent to its origin. Light does not rush. It does not strain. It simply moves at its constant speed, carrying the imprint of its beginnings across distances so large that time itself becomes a spatial dimension. The universe, at these scales, can only be understood as a structure where distance and time are inseparable. Scaling upward again, we encounter tens of thousands of light-years, then hundreds of thousands, then millions. At the scale of millions of light-years, galaxies become the primary actors. The Andromeda Galaxy is more than 2 million light-years away, meaning its light left during a time when Earth's early ancestors walked upright but had not yet formed the cognitive abilities that define modern humans. Observing Andromeda is observing a world from a distant epoch. Beyond Andromeda lie galaxy groups and clusters. These structures span millions of light-years. Their internal dynamics unfold over cosmic timescales. The space between galaxies is vast, but the space between galaxy clusters is larger still. In the realm of tens of millions of light-years, the universe begins to take on a web-like structure. Long filaments of galaxies stretch across space, intersecting at nodes where massive clusters reside. Between these filaments lie cosmic voids, regions measuring hundreds of millions of light-years where almost nothing exists. Galaxies form walls around the voids, outlining shapes that resemble bubbles or honeycombs on unimaginable scales. The distances here are so large that even the light-year begins to feel inadequate. Astronomers sometimes use the megaparsec, a unit equal to more than 3 million light-years. Yet even this is only a convenience, a way of abbreviating numbers that strain comprehension. The structure of the universe simply exceeds the capacities of familiar language. At the scale of billions of light-years, we approach the edge of the observable universe. This edge is not a boundary of matter but a boundary of time. The universe is finite in age, about 13.8 billion years old, and the light we observe has been traveling since the earliest epochs after the Big Bang. As space itself expands, the distance light has traveled may exceed the simple age of the universe. In fact, the diameter of the observable universe is estimated to be more than 90 billion light-years, a number so far beyond human-scale reasoning that it becomes symbolic rather than descriptive. Yet these distances are real. The universe is not metaphorical. It is not an image projected onto the sky. It is a physical structure with layers of emptiness and clusters of matter arranged across scales that challenge every form of human intuition. It is immense in a way that erases our familiar sense of size, distance, and time. This is the quiet immensity we are learning to see. Not through the exaggeration of numbers, but through the disciplined unfolding of scales. The journey through light seconds, light minutes, light hours, light days, and light years is not just a tour of the universe. It is a tour of the limits of human understanding. It reveals the boundaries of intuition and invites us to expand beyond them, not through force, but through patience. As we settle into the vastness revealed by light years, The next step in our journey is to connect those immense distances to the practical realities of human exploration, communication, and scientific understanding. The universe may span billions of light years, but humanity, confined to a single planet, with brief steps into nearby space, experiences it through a very different lens. Cosmic distance shapes every mission we launch, every signal we send, and every hope we nurture about exploring other worlds. It defines not only where we can go, but what we can know. The first way we encounter the implications of cosmic scale is through communication delays, because communication happens at the speed of light. Even this ultimate speed is slow on interplanetary scales. When engineers send a command to a spacecraft near Mars, they must wait minutes for a reply. On Earth, such a delay would feel unnatural. We live in a world of immediate feedback. A message sent through a phone or computer arrives almost instantly. A conversation between two people separated by continents feels nearly synchronous. Light travels so quickly across Earth that its travel time appears to vanish. This limitation may comfort some and trouble others. It suggests a universe where contact with other civilizations, if they exist, is constrained by the same laws that shape our own exploration. Messages, even intentional ones, may take thousands or millions of years to arrive. Replies may take equally long. Interstellar communication requires patience on a scale far beyond any human institution. It becomes an act of faith rather than a conversation. Yet distance also protects. It ensures that cosmic events, supernovae, gamma-ray bursts, collisions, occur far enough away that their destructive force diminishes before reaching Earth. The vastness of space acts as a buffer against cosmic catastrophe. The same emptiness that isolates us also shields us. All of this reveals a universe where distance is both limitation and gift, barrier and structure, challenge and context. Space is not merely the backdrop for cosmic events. It is an active participant. It slows communication, shapes the flow of information, protects planets, and stretches time. It teaches us humility by showing how small our domain is and how recently we have begun to explore it. As we follow these ideas, you may have felt a moment of personal reflection, perhaps a sense of awe, perhaps a quiet discomfort, perhaps a curiosity about how humanity fits into these colossal scales. If thoughts like that have crossed your mind during this journey, this might be a gentle moment to share them. Your reflections, your questions, your sense of scale, all of it shapes how these documentaries grow. If you feel inclined, you are invited to share what resonated with you. That is CTA number 4, offered softly and without urgency. Returning to the universe, we see how distance molds the limits of exploration. Missions to the outer planets require years of travel and decades of planning. The New Horizons probe, launched in 2006, reached Pluto only in 2015. After a 9.5-year journey at speeds unreachable by any earthly vehicle, it flew past Pluto in a matter of hours, capturing the first close images ever seen by human eyes. The entire mission, decades in preparation, culminated in an encounter so brief that it seems almost fragile. But this is the reality of exploration at cosmic scales. Encounters are fleeting. Journeys are long. Information is delayed. Motion is slow compared to the vastness of the distances involved. Spacecraft drift through the silence between worlds, carrying human curiosity with them into regions where no life has ever existed. This silence is not emptiness as we know it. On Earth, silence has texture. It contains the distant hum of wind, the soft movement of leaves, the breath of an animal. Space is silent in a different way. It contains nothing to carry sound. A spacecraft traveling between planets moves through an environment devoid of air, devoid of pressure, devoid of medium. It is silence not by quietness, but by absence. This absence is perhaps the most defining characteristic of the cosmic environment. Space is not crowded. It is not filled with planets and stars at every turn. It is overwhelmingly empty. Even within galaxies, where stars are clustered, the distances between neighboring stars are measured in light years. To scale the Milky Way down so that the Sun is the size of a grain of sand, the next nearest star would still be several kilometers away. The galaxy is a sparse field of tiny lights separated by oceans of darkness. In this darkness, missions like Voyager continue their slow drift. Voyager 1, now in interstellar space, travels through a region where particle densities are lower than anything on Earth. It carries a golden record, a symbol of human culture sent into the void. Its signals grow fainter each year, requiring larger antennas and more sensitive equipment to detect. Eventually, it will fall silent as its power source fades. Yet even after that silence, the spacecraft itself will continue drifting for billions of years, following its trajectory out of the solar system and into the galaxy. It will travel through regions we cannot imagine, passing near stars that have not yet formed, drifting through clouds of dust and gas that may one day become new suns. It will do this without direction, without awareness, without purpose beyond being a small, enduring artifact of a species that once looked outward. This perspective draws us to a profound realization: humanity exists on scales that are minuscule compared to the structures we study. Our missions are fragile. Our presence is fleeting. Our reach is small. Yet our curiosity is boundless. We create tools that allow us to see across billions of light years. We develop theories that explain the birth and evolution of the universe. We send probes beyond the influence of the sun. We build telescopes that capture light older than any mountain on Earth. The contrast between our smallness and our curiosity is one of the universe's quietest marvels. It shows that significance is not measured by size or duration. It is measured by awareness. A galaxy may span 100,000 light years, but it cannot contemplate its own existence. A star may burn for billions of years, but it cannot ask why it shines. A nebula may glow in colors spanning light years, but it cannot reflect on beauty. The ability to reflect on immensity is itself a form of meaning. As our journey draws to a close, the vastness we have explored remains unchanged, but we are not the same as when we began. The universe has not shrunk, nor has it grown. What has changed is the way we see it, and the way we sense our place inside it. Cosmic distance did not ask for our understanding. It asked only for our attention. And by giving it that, by slowing ourselves enough to follow the ladder from human-scale distances to the quiet enormity of light years, we discover something subtle but profound: the immensity that once erased us now reveals us. It reveals us because it shows the narrow but extraordinary window through which the human mind perceives reality. We evolved in a world of forests, rivers, plains, and mountains, places that fit comfortably within the scale of walking, running, and seeing. Our intuition is a reflection of that world. When we move into the cosmic realm, the intuition falters, but the mind persists. We build new tools of thought. We create units like the light year. We design telescopes that pull ancient light from the sky. We craft equations that describe the curvature of space-time and the evolution of matter across billions of years. We reach outward with ideas long before we can reach outward physically. This reaching is not merely a scientific act. It is an emotional one. It grows from a quiet longing to understand the world beyond ourselves. When we observe the night sky, we do not simply see stars scattered across darkness. We see possibilities. Each point of light is a promise that the universe is larger than our daily concerns, larger than our limitations, larger than the stories we tell to give shape to life. And in seeing that, we recognize that our place is neither central nor insignificant. It is simply unique. For all the distances we have measured in light seconds, light minutes, light hours, light days, and light years, the most remarkable distance is the one between awareness and the universe that produced it. Matter arranged in the cold grids of interstellar space does not think. Stars do not wonder. Galaxies do not reflect. But here, on a small world orbiting an ordinary star, matter became conscious. It gained the ability to look outward and describe the universe's architecture. It gained the ability to imagine scales far beyond anything the senses can hold. We do not understand cosmic immensity through instinct. We understand it through reflection, patience, and curiosity. This curiosity is not diminished by our smallness. If anything, our smallness enriches it. When we contemplate a universe so large that light requires billions of years to traverse it, we are reminded that our lives unfold in a narrow sliver of space and time. The human lifespan is brief compared to the lives of stars. Our history is short compared to the age of galaxies. Our reach is tiny compared to the span of the observable universe. Yet our brief moment is filled with awareness, awareness capable of crossing scales no body can traverse. The quiet immensity that seems at first to erase us actually places us in context. It shows us that significance is not granted by size. It is granted by perspective. A single conscious moment in a small, warm room on a fragile planet contains more reflection than an entire star-filled galaxy drifting silently through space. The galaxy moves through time, but it does not know it. The star burns, but it does not question its own fire. Only we can contemplate both. And in contemplating both, we discover that the universe is not indifferent in the way we once imagined. It does not assign value, but it allows for the possibility of value. It allows for beings who can reflect on their own existence. It allows for questions, for wonder, for meaning shaped from experience. The universe does not erase us. It simply does not adjust itself to our scale. It presents itself as it is, vast, ancient, structured by forces beyond intuition, and invites us to grow into an understanding that fits it. This invitation is not loud. It is not dramatic. It arrives as a quiet realization, often felt in moments of stillness. When standing beneath a dark sky. When listening to distant thunder. When watching the slow drift of clouds at twilight. When remembering that the sun we see is 8 minutes old. When learning that the nearest star is 4 years away by light's best effort. These realizations accumulate gently, forming a perspective that widens with each new piece of understanding. And with that widening comes humility, not the humility of defeat, but the humility of belonging. We belong to a universe that exceeds us, not because we are insignificant, but because we are part of something continuous. Every atom in our bodies once resided in the core of a star. Every breath we take is shaped by forces older than Earth itself. Our ability to think, feel, question, and explore is a continuation of processes that began long before life evolved and will continue long after our species fades. This is the quiet immensity that erases us, not by ignoring us, but by dissolving the boundaries between self and cosmos. It shows us that understanding requires letting go of the need for the universe to be scaled to human measure. It asks us to see ourselves not as the center, but as participants in a vast unfolding. When we accept this, we find peace in the distances. The light year no longer feels like a barrier but a description. It describes not separation, but relationship, the relationship between space and time, between what we see and when it existed, between our moment and the long story of the cosmos. Distances become less threatening when we stop asking them to conform. They become a language the universe uses to express its shape. And as we reach the end of this journey, we are left not with answers but with perspective. Perspective that steadies the mind. Perspective that softens urgency. Perspective that offers clarity about what it means to live briefly in a universe that persists across epochs. The distances remain immense, but they no longer erase us. They reveal that even a small life, held for a short time, can participate in something infinitely larger. If you felt that perspective gently shifting during this journey, if the quiet immensity of the universe invites you to keep exploring it at this calm, thoughtful pace, then you are warmly welcome to join for future long-form travels outward. Subscribing is a small gesture, but it helps keep these journeys alive.